Hello, my wonderful dear students who are interested in learning Elixir. This is the basic chapter of Elixir School, and we'll just go through. Feel free to pause the video at any time to practice. In fact, I recommend doing so just to make sure you understand. But here are the things we'll go over. We have basic data types. So Elixir has integers, which are whole numbers, floats, which are numbers that have a decimal point, booleans, which are true and false values, atoms, which are basically like symbols that you can use to name things or refer to things, and strings. And strings are just like words or sentences, or and some basic operations that we can perform on these different data types. Basic math operations, there's Boolean operations, comparison of different values, string interpolation. That means like putting things inside of a string, like inside of a sentence or inside of a word. Double quotes, we'll go over that. And then string concatenation, that's just mashing two words or sentences or two strings together. So let's get started. So this is actually an installation setup, which my other video went over briefly. But here are our data types. So to start, you need to pull up a terminal or a command prompt window where you have the Elixir installed. And I just need to clean mine up. So you'll start something like this or different. But on the command line, you'll type IEX, which stands for Interactive Elixir. And if we hit that, this is like what's called a read, evaluate, print loop. So if whatever we type, like I can type the number 10 and you hit enter, it will read it, evaluate it, it's just 10, and print it. And then loop means repeat. So then take me back to the command line where I can do something else. I can have a more interesting expression like 10 plus 15. So it's going to read it, evaluate it. So 10 plus 15 evaluated is 15, and print it, and loop, and give me back a prompt again to be able to do something else. Okay. So going back to our Elixir School page here. Yeah, this is just the number 255. These are different number systems. So the first two characters represent the type of number. So this is a binary number. It's just indicated with putting a 0B in front of it. But these 0, 1, 1, 0, that's the actual digits of this binary number, which converted to decimal is 6. It will automatically print the decimal version of these numbers. This is octal, so base 8, and that's indicated by these two characters or two symbols, 0 and lowercase o. And then 644 evaluated to automatically, when it prints, it'll evaluate it. Well, it'll again print the decimal version. So this number in octal actually represents, like 644 represents 420. And don't worry about not understanding what in the world is octal or binary, or this one is hexadecimal. So 0x stands for hexadecimal. And what's going on here? There's a letter. This is supposed to be a number. So I'll explain that as the course goes on. But for now, we'll mostly be working with just integers and maybe floats. Probably actually for the whole class, but okay, so now looking at floats. Floats have to have a number on both sides of the decimal point. You can see from this example that if you don't, you get a syntax error. And it tells you exactly what the problem is. So it's a really nice, clean error message. So syntax error Well, it doesn't tell you exactly the problem, but it tells you where the problem is. So it's before the dot. So, okay, before this, well, before that, we need a number for it to be a valid float. And you can also use scientific notation to create floats. So this moves the decimal point. Since it's e negative 10, moves it 10 places to the right. But that's obviously really long. We won't want to type that out. So this is a nice way to shorten that. So that's another decimal type number, but a different notation. Okay, Booleans. Booleans come from, well, the name bool was the, take off the ANS here, just like right there. The name bool comes from George Boole, who was an English mathematician who came up like in the 17 or 1800s. The logic for true false in mathematics, which computers use very much. Like it's very important. So we have true, and it just prints back out true. We have false, and then we have atoms. So these are useful for controlling how your program works, like making different choices based on whether something is true or false. Okay, so atoms are like symbols or names. We use them just to name things, to refer to things, and they start with a colon, and then you have letters afterwards. Um, you can't have a number directly afterwards. It has to be like an alphabetic letter. So we can check to see if the symbol or the atom, as they're called in Elixir, is equal to bar, and using a double equals that tests the equality of each side, and it returns false because they are not equal. Okay. So little secret, Booleans, true and false, are actually also atoms. So there's this built-in function that you can pass whatever to, like whatever your x is, if you think of this as f of x, or is underscore atom, and pass it or insert your thing that you want to test there. So this function actually returns true or false based on whether this, the argument you give it, that's your input to the function, is an atom or not. And so true actually is an atom. Well, that's interesting because atoms we learned up here have to have a colon in front of them to specify them. Well, true and false are special atoms. And Elixir was designed such that we don't have to put the colon in front of it because we're going to use these a lot. So it's nice to just be able to type true. But we can put the colon. It's still valid. And as you can see right here, they're equal to each other. When you use, notice how this is triple equals. Double and equals and triple equals are both tests of equality. Since we're on the topic, let me show you the difference. So the difference comes when you're dealing with numbers. So I don't know why they did it here, because, well, probably just to like give the reader assurance, like these are definitely equal to each other. So triple equals is stronger than a double equals, but they're doing essentially the same thing. So if I use double equals here, that's great. 1 equals 1. What if I do double equals 1.0? Does that equal 1? It says true. Okay. Well, what if I do a triple equals 0? So this again is the stronger. I gotta find my equal sign. Sorry, I don't use this keyboard a whole lot. Don't think about it, and then it'll work, right? There we go. Okay, so triple equals is stronger. And so this is going to return false because these are actually different data types. They're kind of the same, but triple equals says, tell me if they're really, really the same. Like use really, like this is considered or called often strict comparison. JavaScript has it as well. So double equals versus triple equals. Okay, so moving along. Here we're passing a different type of argument to isAtom. This capitalized word thing with a dot and something else called myapp.mymodule. Interesting. And it returns true. It's saying that this is an atom as well. So this is yet another way that you can specify an atom in Elixir using an uppercase letter to start. And that automatically makes this an atom. It's almost as if you had put a colon in front of this. So capitalized letters, and they can have a dot in between. This is just to kind of like organize your code. So modules, these are actually names of collections of functions. Like you can create functions that do stuff, or there's several that are built in that are available to you. Well, for example, like is underscore atom. This function actually is defined inside a module, but because it's so useful and often needed, with some frequency, they designed it to not require a reference to what module it comes from. You can just use it. Okay. Here is something interesting. And if you're reading, you can get this too. And again, pause at any point of this video and practice. But we're still on the command line here. So this is an atom. As you can tell, it starts with colon and it's called crypto. So Elixir is built basically like kind of on top of Erlang, which is another functional programming language. And Erlang has, when Elixir was created, it just decided, you know what? I talk about it as if it has a voice, and it's itself. There was actually a person who created it, but the use of an atom in this case refers to an Erlang module. And so the creation of Elixir had a huge advantage by deciding to build kind of on top of Erlang because, oh, look, there's all these functions that we can already use that we don't have to create. We get them for free just by tapping into Erlang. So this is a function that's called strong random bytes or strong rand bytes. And to be honest, I'm not sure exactly what this does, but the point is, and I could read the documentation and figure it out. But the point is, this is a module name that's an Erlang module. Elixir modules capitalized, and Erlang modules lowercase, and we refer to them by using an atom. So that refers to the crypto module. So it has other functions, I'm sure. That is just one of them that we can use. And another odd thing that's going on here is that we don't have parentheses. So is atom had parentheses, and you insert your argument in the middle of it. But parentheses are often optional. It depends on the context. Sometimes they're required to make things clear because otherwise it can't run because it's ambiguous whether this is an argument or part of something else. But in this case, it's unambiguous because all we have is a 3 after this, so we can omit the parentheses. So maybe some people like that style. It can maybe look a little bit cleaner. So that is that. Okay, let's look at strings. So strings in Elixir are UTF-8. Don't worry about what that means. We will go over that later in class if you do not know already. But strings have to have double quotes, not single quotes, as many or perhaps most other popular programming languages allow either double or single quotes. Elixir, your strings have to have double quotes and double quotes only. But because it's UTF-8, what that means is we can use special characters that are in non-English languages, like this one. And I'm not even sure what word or what language this comes from. I'm guessing Polish, because the creator lives in Poland. So double quotes and cool little U or E character that's not your regular E in English. You can have strings across multiple lines. And if you do that, what it's going to show you back on the print is a \n. So that is how you represent inside of a string like a break across lines. It's called a new line. And for new line that's like the mnemonic to remember it. So this just means like This is really a new line. It's not a /n. It's really a break across foo and bar. And if you type it like that, it will just show you the same thing. To show you how this actually is like really a new line, let's go back to our command line. So what I'm going to do is I'm going to create a variable, and I'm using a single equal sign, and I'm going to say hello \n there, double quotes, enter. Okay, so kind of the same thing we were seeing before. If I hit A, again, it just prints back, reads, evaluates, prints, and loops. So repeat, and I'm ready to type in another command. So there is something in Elixir. There's an IO module, stands for input output, and there's a puts function on that IO module, which will print things for you. Other languages would call this print, but Elixir has puts. So if I stick my variable in there, which again is holding or referring to this string with a \n, which means a line break or new line character. So if I hit that, well, look at that. It printed these on two separate lines because they are on two separate lines. And that's how we represent that inside of the double quotes or inside of the string. A string is basically like also a sequence of characters or letters or new lines. This \n is really like one entity. It's just how you represent a new line. So n for new line. And notice it gave us the OK atom. So functions always return something, a value or something. And in the case of puts, it will do your work for you. It prints whatever you give it, or tries to if it's possible. And then sometimes it's not possible. And then after it does that work, it will just return :OK, which is an atom, which is frequently used in Elixir to let you know, hey, everything worked. It's OK. All right, let's look at some basic operations. So pretty obvious here, 2 + 2, we can use plus to add numbers together, minus to subtract them. A star is actually multiplication, like we would maybe write that x sometimes, or you'd see it written as x in a math textbook, perhaps. But it's 2 × 5, 10. And division, notice it is a forward slash to do division, and it's always float-based division. So it gives me, even though 10 is divided evenly by 5, it still gives me 2.0 because a backslash will always, or sorry, forward slash leans to the right, it's a forward slash, always returns a float. If you have valid numbers on either side of it, you can't divide strings or a number into a string, for example. Let's try that just to see what happens. If we say 10 divided by 5, throws me an arithmetic error. Can't do that. This has to be a number of some sort. Okay, so, but if we do want integer division, we use this built-in function called div. And in this case, instead of just taking one thing, it takes two things separated by a comma. So what we're saying is the first thing, we call these arguments. The first argument, divide that by the second argument. So this is the same, similar as to what we had here. And it gives us a straight integer division, no float, no floating point. And if we did, like, say 3 divided by 1.5, what's that going to do? It's going to throw an error because you have to give it basically like whole numbers. So this is 0 because it doesn't go into that at all. If you do 2, it goes into it once. Just to show you that that is really not just the remainder, but it's actually the division. If I do 7, this should go into it 3 times, and it has a remainder 1, so it won't be 1. It'll be 3. So went into it 3 times. The reason I showed you that is because we do have a remainder function, which in this case, this would be 3 if I was using div, but since I'm using a remainder, it gives me, after dividing 10 by 3, what's the remainder? Well, you have 1 left. Basic math. Okay, so looking at our Boolean operations, so these take values that are considered to be true or false. So we looked at true and false, but in Elixir, as in Python and many other languages, other things are considered true as well. So -20. So first of all, let me name this and tell you what this is doing. This is an operator. It's called the OR operator, so a double bar. So we can say true or true. Well, I mean, that's kind of boring. But in the case, the example we had -20 or true. So -20 is considered true, and this will not compute the right side if it doesn't have to, because it's saying, is this or this true? The first thing that it sees, it reads left to right when this is interpreted. So it gives back the first thing that is considered true, and -20 is considered true. Same thing here. Well, similar thing here. This is the AND operator. So what this is saying is both sides have to be true, and it will return whatever's on the right side if the left side is true. 42, it's true. Most things are considered true in Elixir. The few things that aren't are nil and false. If my memory serves me right, everything else is true in Elixir. So for example, if I say 0 or true, in some languages, including Python, 0 is actually considered false. But if I say it is like 0, is that true? Return it. If it's not, return true. Look, it returns 0 because 0 is considered true. Same thing if I were to do 0 and true, it will fail if this side is considered false. Since 0 is considered true, it will return the right side. So it returns true. What if we had done nil, just to drive the point home? So nil is actually also an atom. It returned nil because it failed. So it just returns whatever fails to make this whole statement true. This, because I'm saying and this is true and this is true. This comes from George Boole, kind of his mathematical logic that he came up with that all programming languages use today. The other thing I said was false is actually false. And so, yep, it saw that. This is false. I'm just going to return false. I'm not even going to skip over to see is the true or the right side of this, is that true? Cool. All right. This exclamation point, often we call it bang in program speak. And that's not just Elixir, that's all languages. So that can basically reverse anything. So if I give it false, it will return true. Reverse the Boolean value. If I give it 42, as you saw, it's going to be false because 42 is normally true. So is 0. So this says not. It's like, take whatever this is and reverse its Boolean value. So that's false. Okay, so we have something else. We have and and or, which are kind of like these, or and end. They work a little bit differently because you actually have to use the atom true or the atom false on the left side of these. And then you can see it does the same thing. It returns the right side of and if both sides are true, and it returns whichever side is true first. So false wasn't true, so it returns true. And then not false, that's kind of like our exclamation point, also known as bang. So bang 1, that's going to return false. But I can say not. I can't say not again, because these and or and not have to have false as their, in the case of not, that's the first thing that comes after it. In the case of or and, it's the first thing to the left has to be true, the literal atom true or false. But as we see right here, it can be something else. Yeah, C42 won't work. Has to be true or false with and. And not 42 will not work either. But bang 42 will, exclamation 42. So little side note where and or come from. Okay, now we have like comparisons of values that can be greater or less than each other. I won't go over these. Experiment with them on your own. Pause the video if you want to do that and try some different values. We have not equals, so that's going to return true because 1 does not equal 2. We have 2 equals 2. And I showed you the strict comparison triple equals previously. And this is less than or equal to. We could also do greater than or equal to. So this is true. 2 is less than or equal to 3. Okay, and I already showed you strict comparison. 2 equals 2.0 is going to return true, but if you make it strict, it's false. Okay, here's something that's kind of weird. And why would you want to do this? So we went over, there's number types, atom types. So what this little note is saying here, if you're reading it, you'll know that these different like data or value types, we haven't gone over these. These are like more advanced ones: function and port and PID and tuple and map and list and bit string. But basically, what this is saying, this is very logical. Like you would see like some mathematical proof or something or statement saying that number is less than atom, atom is less than reference, reference is less than function. So basically, what this means is that all data types in Elixir can be compared to each other, like if they're greater or lesser than. And that actually is helpful when ordering things in computer memory and trying to search for things fast. It's nice to be able to, regardless of the type, to be able to just search through things and say, is this greater than that? And that gets into some more computer sciencey stuff, but which we won't really get into too much in this course. Cool. So yeah, it just again what I was telling you, we can any types can be compared. Like the atom hello can be compared if it's greater than 99, which happens to be true. And you don't have to. All atoms are going to be greater than numbers, than any number, always. So, and then this is a different data type. It's like a collection of 2 atoms and the list of numbers. And this is false because this type of data collection is not greater than a list. So, okay, here is something important for assignment number 2. We have something called string interpolation. That means like inserting things instead of a string. So you can actually insert a string instead of a string. So we have the name Sean, and then I can use double quotes, say hello, space, and then here's where we use some special symbols that will allow us to interpolate, that fancy word, or insert this variable, which we set up here, into this string. So, and it returns hello, Sean. So you have to have the hash sign, curly open brace, your variable name or expression, curly closing brace, and double quotes. And then since we're in interactive Elixir, it just prints it for us. So what if you had a number in there? What if you wanted to do like, my number is hashtag, and I could say 2 plus 3, closing curly brace, double quotes. So you can actually insert direct like expressions, mathematical expressions. If they're valid, this will return the evaluation of that. My number is 5. Okay. Here's another special type of symbol that basically does the same thing we did up here, but a different way of doing it. So we could write our hello with a space and a closed double quotes. And then the variable we set here, which is called name, we can concatenate, another fancy word, just means put together 2 strings. We always use this when we're talking about strings, typically. I would say always. Maybe I'm wrong on that. But in any case, so yeah, we can concatenate 2 strings together and essentially gives us the same thing we had up here. So that's the end of the lesson. Thanks for listening. Please practice every day. Moments every day will help you a lot. Get your Elixir programming skills up to speed.